2, didn't I?
It should be
Dang it.
64, that's why, yeah. That's why I did it 5 times, but when I saw hers, I was like, right.
Should have been hopefully easy. You should have a 2 row that's empty. This one, so real quick, what does this really mean? This means 10, 11, 12, 13, 14, 15, 16, and 19. Couldn't I could cut that in half again. So like if I put a 4 and a 5, that would mean 4-0 to 4-9, and this would mean 5-0 to 5-9. Well, then I just have 2 big-ass rows of data that don't really give me a visual of anything. So then I get better resolution. So up here I'm going to put the O's up to 4. What was it? 0, 2. And then 4 would start with 4, 5, 5, 6, blah, blah, blah. And this will be O, 1, 1, blah, blah, blah. And then this will start up again at 5, right? So 5, 0, 5, yeah, 5, 5, blah, blah, blah. How we doing? I mean, that's just to show you some of the flexibility in this.
They don't have to be ordered, right?
They don't have to.
Okay.
Yeah. Because it's really the length of it that gives you the picture.
Yeah.
Okay. Maybe. And of course, your little blah, blah, blah should have numbers. Number 3, the work's been done. The work's done. I don't have to do much work at all then. How many people were surveyed? Well, what kind of table is this? It's a frequency distribution, right? So it's the height of the bar tells me how many things were in that category. And in this case, I'm not talking about things, I'm talking about people. So for example, there were how many people in this first one? 11. Most people got 11. 11. It's not 12 because it's not quite all the way. So 11 plus 6 plus 2 plus 1, you get 20 people were talked to. So don't sit there and tell me they don't tell me. No, they don't. You just got to put it back together. They broke them up into groups, put them all back together. Right? Don't divide. Right. How many classes are there? How many empty classes are there?
2.
Good. So there's not just 4 classes. There's
6.
Because 2 of them are empty. Bless you. Class width, I got no work to do because they already did the work. Pick a class. How wide is it? 20. Done. These are the same number. It doesn't mean shit, right? It just is a coincidence. Sorry. At least, this drives me insane. You must be at least this tall to ride the ride. So if I'm this tall, can I get on that ride? No. You hope to God the operator is able to tell what at least means. We're just going to have a bunch of kids just flying through the air. Sorry. Jeez, Jeff. Laughing about kids flying. A little joyful. I don't have any kids. So at least means that or more. So how many people had to last at least 40 weeks? How many total people? 3. Gracias. So then 3 out of 20. And that's actually a problem we did on the warm-ups. I like it. And then we got this guy. The Mamma Jamma here. So, sorted, bless you. There was, 79 minus 61 divided by 5. Gives you 3.6, you round it up to 4. If you do it the textbook way, really want this to make sense, even though I don't personally like it, it still has to make sense. If you put 61 down, this has got to be 4 away, 4 away, 4 away, 4 away. You can't put 65 here also because then it's ambiguous as to where 65 should go. So you put 64. 4 away, 4 away, weem away. Oh, weem, no, Jim. Now watch. Watch. If I go to graph this, where do I start? No. That. I start at where? Because I chose this way to do it, not the inequality way. So I can't start at 61, I start at 60.5. And again, we went over why. Somebody pointed out to me, won't there be a gap here? Well, that's why those 0.5s exist. Because if I boost this up to 64.5, and I boost this down to 64.5, don't they match up? There's no gap. If you don't like that, well, just do it the other way. Do it the inequality method. Ain't none of that shit in there. Yes.
So we can write it as the 61 and 64, but when
You
we
have to.
graph it on the histogram, we have to include the
You have
0.5.
to. I like it. Whole numbers, boundaries, decimals. Now, if you do it the inequality way, the first class would be 61 to 65, but not including 65. And then 65 to 69. The nice thing is here, you can see the width any way you look at the damn thing, right? And then my boundaries are my limits. So this is the person that has no boundaries. You can stand right on them. Hey man, how you doing? I'm alright. Okay, some of you guys can. Alright. So just pick a way. If you want to do the book method, you better do this shit. I don't want to see no whole numbers down here if you do it this way. Alright, so what'd you guys get for these frequencies? I think it was 2.
11, 13, 17.
Okay. And thankfully they all have to be. Do that quick check right there. If you get 34, you left somebody out. Get 36, you made somebody out. And now just the relative frequency would be 2 out of 35, which comes out to be 5.7%. 11 out of 35 comes out to be 31.4%. Now watch this. What's 2 plus 11? What's 2 plus 11? 13. So what's 13 divided by 35? It's this plus this. It's 37.1. Isn't that what you got? Yeah, whatever, math boy, hard. 7 out of 35 is nice because that's 1/5, which is 20%. And then 2 out of 35 is nice because I already did it. Now I rounded a bit on those, right? I rounded to one place. So we're going to do something by hand, round it to one place because you can't even be that precise by hand. So, but you want the math to kind of work out decently well. So when you do this cumulative frequency, come on, one over there. And then you get what? You get 74.2.
Yeah.
And then 94.2. And then finally, 99.9. Why is it not quite 100? Because we rounded. So we just happened to round down one more time than we rounded up. So it doesn't quite fill itself. That's fine. If you get 97, no. If you get 104, no. So what works? Like 99.6 to 100.3 or something? You know, somewhere it's got to be really pretty close to 100. Maybe. You guys doing all right?
Yeah.
Okay. Now, I already started this scale off. What's nice about this? Why is this going to be easy now?
Because it's a relative frequency.
Well, okay. What's nice about this scale? What's my width?
5,
No.
4.
So just go I by 4. There's no thought process here. I just know they're all 4 apart, aren't they? You guys with me?
Yeah.
Notice how 68.5 would be that up by 0.5. I mean, so it works out. Of course it does, because we created this shit. It's going to work out. Now, what kind of scale am I going to use here? I want this to be relative frequency. So I got to go up to how high?
40.
Well, I didn't get a 40.
But you can do.
Oh, I see. Yeah. So you get this guy has the place. I'm with you. So yeah. So what'd you guys do? What scale?
5.
You with the 5s? 5, 10. Oh shit, Jeff. It's probably gonna be too small. 15, 20, 25, 38, 35, 40. Okay. That's really nicely done, Jeff. Shut up, Jeff. Myself shit. And then you just now should be the easy step where we just make the bars as tall as they need to be. First one should go up to almost 6. Should just over 5. The next one goes up just over 30. The next one goes up just over 35 a bit. And then down to 20. And then back down to 5. Does that look roughly normal? Does that look roughly normal? Yes. What have I left off, first off?
0.
No. 0 doesn't matter, so I left out on purpose.
Zero labels.
Good. So what should this be?
Slices.
No. Oh,
Father's Day?
father sites. Isn't this father sites?
How about?
How do you know that? Well, that's what I said. It's father sites. So that's got to be physically descriptive, not just classes. Not good enough. Everything's classes. What the hell?
Right.
I don't know what I'm looking at then. So most fathers had heights where? Most fathers had heights from
68.5 to 70.
Yeah, okay, so that's what we call, well, eventually we're going to learn that's called the modal class. The mode is what happens the most.
So it's okay to keep it as relative frequency.
Well, I asked for a relative frequency. Yeah. If I would have said create a frequency histogram, you better use the whole numbers.
I mean, for the label.
Yeah. I put RF just for real freak. Real freak. Is this approximately normal? What is a normal curve? What's a bell curve look like? Bell curve, you guys have heard of the bell curve? Did I talk about that before? Bell curve. If you hear somebody say a curved grades, what does that mean? They picked the curve up and they moved it. Now, when I curve grades, I pick it up and I also squish it a little bit as I move it. Okay? And you're like, well, just do that when you need to, Jeff. Especially when my grade's low. Why don't you do that? So is this approximately normal? Does it start low, go high, and then go low again? Yes. It's not quite normal. This is a little too tall, right? This is like somebody with a broken finger trying to flip us off, but you guys see that? Can't quite get that one down. Anyway, all right, it's just for me again. So whenever I see a normal histogram, it looks like somebody flipped me the bird, but especially if there's 5 of them. Right? It's just me. That's all right. So any questions from that? Okay, cool. So we're going to do one more chapter, and then we're going to head out. One more section. Let's not get over ambitious, Jeff. One more whole chapter. We're going to do the next 100 pages. That's all, kids. Let's see if you're working. Yeah? Good. So, I found out that they don't do this anymore, but they used to, for the SAT, they used to give you your grades in a certain way. And let me first describe why why giving it a certain way would make more sense than just a number. Every time how many of you guys have taken like the SAT? Anybody? Everybody knows what the SAT is, though, right? It's that crazy S test that determines your whole future, supposedly. Thankfully, fewer colleges are basing so much on that because it's horribly biased demographically and otherwise. Anyway, so why is it kind of unfair to compare your grade on the SAT to somebody who took it some other weekend? Do they always give the same test? Of course not, because it's nowadays you can take a picture real quick. I got a picture, man. You can look. I got every page. You study it, and then of course, but they change the freaking test, don't they? If I change a test, could I randomly make it a little harder? Okay. So if you take the test on the harder day, and your friend takes the test on the easy day, that's a little mean, isn't it? You understand? Right? So if somebody in a math class with an easy-ass teacher gets an 80, and you're in class with, like me, I don't know, it doesn't give you easy-ass grades, and you get a 70, that's not really totally fair. So a better measurement to compare between two is relative position. What's your relative position grade? So like my first grade in grad school was a 19 out of 41, which is less than 50%. So gave me that paper back and I saw it and I'm like, what am I doing? I shouldn't be here. Oh shit. And then and the teacher came back by me and said, oh yeah, good job, Jeff. I'm like, what is happening? What do you mean good job? I got 19 out of 41. And that's because the average grade was like 21 out of 41. So that would be a curving situation, right? So that grade, if I told you I made less than 50% on a test, you go, oh shit, man, that's bad, I'm sorry. But relative to the class, that was good. I was above average, come to find out. I was ready to just go, I'm just gonna go home. I'm gonna, I don't know, drive Uber. Uber didn't exist back then, so I'm gonna create this company. Yeah, I have some problems too, though. You guys semi with me. So on the day, if you took it the hard test SAT versus the easy test SAT, I'd rather have a position, where was I relative to everybody else? Because if I make a harder test, everybody's grades should probably go down a little bit on average, right? So then my lower grade is still relatively the same position maybe as my friend. Okay, maybe. So this is an idea of relative position. And what we call this thing we're going to get into, there's several different ways to do relative position, but the first basic way we do is called percentiles. Yeah. So if you make an 80 on a test, that means you got 80%. Right? For some teachers, that means you got 80% of stuff right, let's say. If you got the 80th percentile, that doesn't mean that necessarily that you got 80 right. That just means that 80% of everybody else scored lower than you. You with me? So 80th percentile on a test, you scored higher than 80% of everybody else. Is that good? That would be a place I'd rather be rather than 20th percentile, which means you only scored better than 20%. So what about in a race, the time it took you to run a race? Do you want a higher percentile or a lower? What would mean if you ran a race and you had the 10th percentile time? What does that mean? 10% of everybody else took took less time. You with me? Percentiles always mean the same shit. 80th percentile means 80% of everything else was below your score. So if I'm in the 10th percentile time to run a race, is that good?
Yes.
No.
I love you guys. I'm just looking at you. Yeah, he's looking at me. No, yes, no. Yes. Both? Is it Schrodinger's cat? No. It's good. Only 10% took less time than you. If you're the 90th percentile, it means 90% took less time than you. You're coming in last, pretty much. You're at the end of the group, aren't you? You guys kind of follow. Not really? Okay. What about speed? Let's talk about speed. The speed, if you're in a race, do you want to be a higher percentile or a lower percentile? So if you're in the 20th percentile speed, what exactly does that mean? 20% of everybody else went slower than you. I love you. Percentiles, wait. Percentile always means the same damn thing. If that percentage had a smaller number than you, it always means that. Always. You guys with me? So if we're talking about speed, if your speed was 400 units per unit, and you're in the, I don't remember what I said, the 20th percentile, that means that only 20% went slower than you, had a smaller speed than you. 80% had a higher speed than you. Your car needs some work, or your whatever it is. You had a question, then you got a question.
Well, I was just going to clarify. I think I personally got confused because, for instance, on a test, you would want a higher number.
This is what I'm trying to get at. This is where you got to be careful. Percentile means the same damn thing always. Always. That percentage, lower. Is lower always worse? No, that's what the point I'm trying to make. What does percentages mean? Always the same damn thing. What's better or worse? Well, that's up to us freaking humans, right? We got to figure out what's better or worse. Yes. Yeah, so if I'm talking about the speed, and I got the 20th percentile speed, my speed was better than 20%. So like 20% of people had a smaller speed than I did. So was I one of the fastest or one of the slowest? Slowest. No, I didn't say that. Why would I ever say that? What does 90th percentile blank mean? 90% of all the other stuff was lower. Period. That's what 90th percentile means. 90% of all the other numbers are smaller than that. Alright, so what if it's speed in a race? That's good. 90% of everybody else went slower than that. Only 10% went faster. That's a good speed. Yes? No? What if it was amount of money you pay on a repair for your car and you're at the 90th percentile? That means that 90% of people paid less than you did. Is that a good place to be? No. You guys start to see. How do you interpret a percentage? It's different based on the situation, but what does a percentage mean? A percentile mean? Always the same damn thing. It's that percent below your number. So if you're playing golf, even if you don't play golf or like golf, does everybody understand that is a lower score or a higher score better?
Lower is better.
Lower score is better because that's how many times you have to hit the damn ball. And you want to hit the damn ball less. Right? That's more impressive. Right? Get it in that one shot, that's impressive. Rather than 7 shots, you suck. Right? Or you're having a bad day. So in golf, do you want a score that is a higher percentile or a lower percentile? Maybe think about it for a minute. In golf, do you want to be in the 90th percentile or the 10th percentile?
10%.
Because then only 10% will have a score lower than you. 90% will have a worse score higher than you. You guys with me? So there's two things here. What does a percentile mean? Always the same frickin' thing. What does the 40th percentile mean? 40% of the numbers were lower than my number, right? If it's a chess grade, that's kind of bad. If it's a golf, that's pretty good. Did it better than half, right? So yeah, the interpretation of is it good or bad? Holy shit, that's another like layer on it. But what does a percentile mean is always the same damn thing. Okay, maybe. So the problems in the homework give you situations like how long somebody had to wait at the DMV or how much money they pay for a car report, those kind of things. Is it good? Is it bad? Okay. So if I said I had the 80th percentile, that's another way to write percentile. 80th percentile, what do you got, Jeff? 80th percentile on the number of mistakes I made on a test. Number of mistakes, right? My number of mistakes was at the 80th percentile. What does that mean, number one? Just what does it mean? Not is it good or bad, just what does it mean? 80%
Had less.
of the other students had less mistakes than you. That's just what it means. That's no judgment, right? Just that's what it means. So that's one question I could ask is just tell me what the hell it means. 80% of all the other people made less mistakes than me. So now you can say, is that good or bad? That's bad. I made more mistakes than 80% of the people. That's not a good place to be. Maybe you guys see that's good. So you're right. There's two layers to this. One layer is the same. Just what does a percentile mean? And then it's, all right, is it good or bad? Okay, I like it. So let's focus on this 80%. What do I got? I got like 10 minutes left?
Yeah.
Right? Okay. 5, okay. 7-ish. I got 10 minutes left. Man, you want to leave before I'm done, that's fine. That's on you. So let's do, here's the symbol for 80th percentile. That's the symbol for 80th percentile. Now, let me make up some data. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so small sample is easier to work with. We'll see what percentiles, how we can calculate a percentile. But it's a small sample, so it's not perfect. Can somebody tell me a guess as to which number represents the 80th percentile, now that we understand better what percentiles mean? What's a guess? Wait, somebody say 27? So this is one guess for the 80th percentile. Why do you think it's 27? Oh, I see. It's on the higher end. Make a guess that's more specific than it's just on the higher end. 80th percentile versus 70. I want the 80th percentile. Then which number? 30. Has how many numbers above it? 2. 2 out of 10 is 20%, so that makes sense, right? But 30 only has how many numbers below it? 7, which is what percentage? 70%, is that right? But if I make it this one, how many numbers are below it? 8? 80%, that's right, but how many numbers are above it?
1.
So only 10%. It should be how much above it? 20%. Now stay with me, stay with me. So what's the number that has 80% of the data below it and 20% above it? 31. Kick-ass, I love it. 31 doesn't have 31 have 80% below it?
Yep.
Yes, and doesn't it have 20% above it? Yes. How did I run out of time? All right. So the 2 steps to find a percentile for any list of data. How long is this list of data? How many data points? 10. So when I use the number 10, you're not going to always use the number 10. Why am I using the number 10 on this one? This is 10 numbers. If you have 28 numbers, you better use the number 28. Okay. So does this first statement make sense? The 80th percentile should be the number that's about 80% of the way in.
Yeah.
If you start here and go 80% of the way in, that should be at least close, right? So the first step to finding any percentile is to take that percentage of the sample size. In this case, it's 10. What's 80% of 10?
7.
Almost. 8. Right? 0.8 times 10. You're going to love this shit. There's only 2 possibilities here, so don't yell at me about, I can't memorize those. Wow. If you get a whole number, that means average that one with the next one. Isn't that what we did? What's the 8th number? And the next one? And we averaged them. See that? So we did the right thing before we even knew the rule. Well, the rule comes from what frickin' makes sense. That's why. So I got a whole 8. So I'm going to average the 8th and 9th. Right, so 30 plus 32 divided by 2 is 31. Yay! If you get anything else than a whole number, here's what you do. So like if I wanted to get P17, what's the 2 steps? P17 is the what? 17th percentile. So first step would be do what?
17%.
17% of 10 in this case. 17% of 10, which is 0.17 times 10, which is what? 1.7. Is that a whole number?
No.
No. If it's a whole number, you round that one with the next one. Sorry. Get a little excited. If it's anything else, a decimal at all, you round up and you take that number. So I'm going to round it to 2. What's the second number? 11. That's the answer.
always put your data in order first.
Beautiful, exactly. So that's the next thing I was going to say. The only reason that works on this data is because it's in order. If they didn't have to be in order, I could make these anything I wanted to be. What do you think another name would be for P25? What's special about the 25th percentile?
Quarter.
Yeah, it's like 25% of the way into a football game is the first quarter, right? So this would be Q1. P50 would be,
Q2.
P75 would be.
Q3.
Good. All right. So, I love you guys. You guys are like, what the shit?
Homer City rough.
Right?
Say again? It was supposed to be a up arrow, round up. Yeah. All right, guys. So we will pick up and do more with this next time. I just want to get this idea in your brain. You're having trouble sleeping. Thank you.